These are some common shapes that you should be aware of, like right rectangular prism. The volume of a right rectangular prism is length into width into height. The volume of a sphere is 4 over 3 pi r cube. This is very common. Although these formulas will be given at the start of every math section, I'd still suggest that you memorize these formulas to save you time. So what do we do to find out the volume of a solid? To calculate the volume of any solid, find the volume of formula for the solid. Like if a sphere is given, the volume will be this. If right rectangular prism is given, the volume will be this, and so on. Plug the dimension into the formula and evaluate the volume. It's very simple. Let's have a look at this example. Fifi has a model of the moon in the shape of a sphere. If the model has a radius of 10 centimeters, what is the volume of the model in cubic centimeters? Now, if you remember, the volume of a sphere is 4 over 3 pi r cube. That's it. That's all you need to do. Volume equals 4 over 3 pi r cube, and r is given to us. R is 10 in this scenario. Just replace r with 10 and we will have our answer. V equals 4 over 3 pi into 10 cube. This comes out to 1000. 1000 into 4 is 4000 over 3 pi. This is our answer. If you simplify this, you will get 4189 cubic centimeter. This is our answer. Next example. A puzzle box is shaped like a rectangular prism and has a volume of 240 cubic inches. Now the volume is already given to us. If the puzzle box has a length of 10 inches and a width of 8 inches, what is the height of the puzzle box? It's very simple. You apply the formula and you will get your answer. The volume of a right rectangular prism is this, length into width into height. This is something that you need to remember. So you see, if you already remember, you won't have to change the page and go back to the first page and look at the volume formula. So volume is length into width into height. Volume is given to us, which is 240. Length is also given to us, that is 10. Width is 8 and height is what we have to find. There you go. We have the formula. Just do the math and get your answer. 240 equals 80h. H equals 240 divided by 80, that is 3 inches. This is our answer. Next question. A pyramid has a square base with a side length of 8 centimeters. The height of the pyramid is 3 over 4 as long as the side length of its base. What is the volume of the pyramid? Interesting. So if you remember the formula, the volume of a pyramid is 1 over 3 into length into width into height. You should remember this. If not, you will have to go to the first page and then look at the formula, which is this. Okay. Now the height is not given to us. The height is 3 over 4 as long as the side length of its base. Base is a square and we know that all the sides of a square are equal. So height is basically 3 over 4 into 8, which is 8 divided by 4 is 2, 6. Now we have everything. We have the length, width and the height. Let's just put the values into the formula and see what do we get. The volume will be 1 over 3, length is basically 8, width is also 8 because it's a square, and the height is 6. This is our answer. 6 divided by 3 is 2, 8 into 8 is 64, 64 into 2 is 128 cubic inches or centimeters, sorry. Cubic centimeter is our answer. Now let's evaluate the effect of changing dimensions on volume. This is very important. I've seen a lot of questions on this topic. So when a linear dimension to the first power, very important, for example, the length of a rectangular prism or the height of a cylinder changes by a factor, the volume of the solid changes by the same factor. Very important. For example, let's say we have a cylinder whose radius is 2 and the height is 6. What will be the volume of this cylinder? Let's calculate. The volume is pi r square h. Plug in the values. Pi r is basically 2. 2 squared into height is 6. So 6 into 4 is 24 pi. This is the volume. Now let's have a look at a different scenario. What happens if I double this height? Everything else remains the same. We have the same cylinder whose radius is 2, but now the height is 12. We have doubled the height. Let's calculate the volume. The formula remains the same, pi r square h. Let's plug in the values. Pi into 2 squared into h is 12. 12 into 4 is 48 pi. You see, the volume basically doubles. Why? Because the power of h over here is 1. However, if I change radius by a factor of 2 or 3, the volume won't change by the same factor because it's a square. Let me explain through another example. So when a linear dimension to the second power, for example, the radius of a cylinder or cone changes by a factor, the volume of the solid changes by the square of that factor. This is something that you need to remember. Let's take the same cylinder we were talking about. Everything remains the same. The radius is basically 2 and the height is 6. We know we have already calculated the volume. It was 24 pi. Now, let's look at a different scenario where we reduce the radius by half. Let's say radius is 1. It is reduced by half. So you see the volume is basically pi r square h. So if you reduce the radius by half, the volume will be reduced by the square of the factor. So if the radius is reduced by half, we are basically doing this. I'm just talking about the radius for now. So you see, if you reduce the radius by half, the volume will change by a factor of 1 by 4. Calculate, plug in the values and you will see. So if the radius is 1, what is happening? Pi into 1 square into h, which is 6. What do you get? 6 pi. So it is reduced by a factor of 4 and not by half. This is something that you need to remember because we have a square over here. Another very important thing to remember is that in a lot of questions, you won't be given values for radius or the height. You will just be told that the radius decreases by half, so what will happen to the volume? It's very simple, just apply the formula and do the calculation. So let's say the volume of the original figure is basically pi r square h. Now when the radius is reduced by half, what happens to the volume? Let's say this is the new volume. Let's plug in the value for the radius, which is pi into 1 over 2r. That's all you need to do. Do the calculation and you see what's the new volume that you get. You will get 1 over 4 pi r square h. You divide both these and you will find out the factor. Let me do the math for you. So we have V original over V new, that is pi r square h. This is the volume of the original figure divided by the volume of the new cylinder, which is 1 over 4 pi r square h. This will cancel out and what do you get? You get volume of the new figure is basically 1 over 4 volume of the original figure. There you go. Let's have a look at this interesting question. Right circular cylinder A has a volume of 64 pi cubic feet. Which of the following right circular cylinders have the same volume as cylinder A? Interesting. Okay, let's have a look at the option choices. A cylinder with 2 times the radius and half the height of cylinder A. Let's do the math and find out what is happening. Let's say the volume of our original cylinder is pi r square h. This is our standard, which is basically 64 pi. Now let's evaluate option choice A. Let's say this is the new volume in which the radius is changed by a factor of 2 and height is decreased by half. So we have pi into 2r squared into half h. This is what we are looking at. Do the calculation and see what do we get. We get 4 pi r square h divided by 2, which is 2 pi r square h. In this scenario, the volume basically doubles. You see, this is our original volume, pi r square h. But over here, we have a factor of 2. So option choice A is wrong. Okay, let's evaluate option choice B. Let me use green color for this. A cylinder with 2 times the radius and 1 over 4 the height of cylinder A. Let's do the similar calculation that we did earlier. The original volume, the new volume will be pi into 2r squared into height, which is basically 1 over 4h. Let's see, what do we get? We get 4 pi r square h divided by 4. Over here we are getting our original volume, which is pi r square h. Pi r square h. Definitely B is our answer. This scenario will give us the same volume as cylinder A.